Okay, so like we said, they've given us absolute value of u, absolute value of v. So they've given us the magnitudes of these vectors, but we don't know the direction from this information. We only know the absolute values of them. But we do know the angle between u and v is 120 degrees. So we're going to try to recreate what these two vectors may look like. We don't know what directions, again, they are heading. But this will be our u, and we'll say v is a little longer. Okay, so here's our vector u, which is 4 units. And this one is 5 units, and this is our vector v. We know the angle between it is 120. What have I done wrong here if I'm trying to draw this relatively to scale? Yeah, that's an acute angle I've drawn. So let's fix that. That would make more sense. There you go. That worked out good. So this makes a little more sense. 120 degrees. Okay. We have an obtuse angle. So we have 120 degrees. And remember, they said they want something that is of the same direction of u plus v. Okay? U plus v. Well, let's think about that. If I'm traveling across u and then going to v, or vice versa, we're going to end up at the same point. Okay? Remember, it doesn't matter the order I do v plus u or u plus v. And just to show you the idea, we'll use the parallelogram sequence to solve this one. So here's our other u, and here's our other v. Okay? So what happens here is this is the equivalent of vector v. This is the equivalent of vector u. The resultant, or u plus v, is essentially this vector here. That's our vector u plus v. We can also give it another name, but we're going to call it u plus v. Okay? So we have that. That's our resultant vector. Using this information, we want to try to find out what the unit vector of that would be. And unit vector, remember, unit vectors are equal to 1. So we're going to have to find a scalar of these vectors, because we do know magnitude. We know that this is 4. We know that this is of a scale of 4, and this is a scale of 5. Much larger than a unit is only 1. So most likely we're going to be using a scalar vector, right? Because we want it to be a unit vector of uv. It's probably going to be much smaller, because if each of these were 1, what would uv be when it adds together? And we're going to try to figure that out. So I'm going to highlight a triangle, because again, we're using our triangle rules. We'll call this our triangle here. So we've created a triangle. We know that this measurement is 5, or the magnitude of that is 5. Magnitude of our other u is still 4. First of all, we need to find the magnitude of our u plus v. Okay? And in order to find the magnitude of our u plus v, how are we going to solve that? Anyone know? First of all, can I find out the angle of anything else in here? Right now I don't have enough information. I need to find an angle in this. What angle can I solve for? One up the bottom right? Yes, very good. How do I know what that is?
60.
How did you know it was 60?
Because it's like the other top right one is 120 degrees.
This one's 120. Good.
And 360 minus 240 gets you 120, and divided by 2.
Good. Both of these are 60. A four-sided shape must add up to 360 degrees. Another way you could have done that is because these are, what is the name of it? Something you learn in grade 9. Essentially, here's the idea to do it. I can't remember the specific name. But this creates a C. And in that C, the two angles must add up to 180. So we knew one of them was 120. Therefore, we take 180, subtract 120, and we get our other angle, which is 60. These two are opposite angles, so they're the same. They're both 60 degrees. So I now have a unit value of this side, an angle in between, and a unit value of this side. Can I use sine law? Why not? Yeah, I don't have a ratio. So I can find this red side here, though, or uv essentially, by using cosine law once again. So we'll write out our cosine law very quickly. I'm going to call this, again, u plus v. So in this case, u plus v squared, which is our c squared, you could call it, is equal to u squared plus v squared, or a squared plus b squared, minus 2ab minus 2 times u times v cos c. And in this one, we're going to call it cos, well, I could call it cos uv. I'm just going to give it a symbol. We'll call it theta, okay? Cos theta, barely fits. Well, we're still trying to find uv. So, is equal to, vector u we know is 4. Vector v is 5. 2 times 4 times 5. And we know the angle, cos 60. Okay? Gives us 16 plus 25 minus 40, cos 60. 41 minus 40, cos 60. Now, don't get confused here. A lot of people make the mistake. You cannot subtract 40 from 41. 40 needs to be multiplied by cos 60 in this question. So let's find out what 60 cos is. Oh, okay, 0.5 times 40 will be 20. Just to prove it to you. There you go. 41 subtract 20 gives us 21. Am I done? Is that distance 21? Square root. Very good. Because this is technically absolute value of u plus v square rooted, because it was our c, or squared, sorry, u plus v, absolute value, is equal to the root of 21. I'm going to leave it as a root. Okay? So I know this is root 21. We have that information here. Now, in order to find out the unit vector of this, we actually have to multiply. Okay? We have to multiply by the 1 over our value of our added vector together here. Okay? So what I mean by that is I'm going to write up a little rule here on the side for you guys. So the unit vector can be written like this: 1 over absolute value of x, and x is our vector in the middle here, to the actual vector of x. Okay? So we're going to find out what these two are. Well, our resultant vector, in this case, or our x, is u plus v. Okay? This thing here is u plus v. And the magnitude, or absolute value, of u plus v, and that's what we're trying to find. So in order to find this information, I'm going to plug in what our values are. We are 1 over absolute value of u plus v times u plus v, not absolute value. Okay? Well, we know the absolute value of this. Those are our unit vectors. uv, those are of the power of 1, or sorry, magnitude of 1. Our u plus v absolute value is root 21. So we get 1 over root 21 times u plus v in this instance. And because it's a scalar, okay, we're going to use distributive property. We multiply. Okay, and we'll try to make sense of what this is. This is 1 over root 21u plus 1 over root 21v. So what the heck are they saying to us here? This can be very confusing. Let's try to make sense of it. What this is saying is, first of all, the actual value of this, okay, is pretty far. Okay, it's root 21. Okay, root 21 is, anyone know what our number is in that case? Root 21, 4.58. So a magnitude of something like 4.58. Okay? But remember, we said we wanted this to be a unit vector. So it has to be a scale of 1. We said this was a unit vector. Okay? So because this distance here, and I'm just going to draw it out again in red here. This is our u plus v vector. U plus v. We know it's of the root 21. That's the magnitude of this vector, or it could be also known as 4.58 approximately. Not exactly. Well, we wanted a vector in the same direction as u plus v, and we know that this direction is here, u plus v. But the magnitude is too large, 4.58. That's not a unit. A unit vector has to be of a scale of 1. So in order to find the scale of 1, we have to essentially divide that vector by this number. Okay? So in each of these cases, we do 1 over the absolute value of that and multiply it in as a scalar. That's what we've done here. We put 1 over the value or the magnitude of that vector, which is root 21, and then we distributed it to the unit vectors, u and v. So in order to find a unit vector of uv, we needed to have a magnitude of 1 over root 21u, so that's the distance of it, plus 1 over root 21v. Let's try to piece this a little more, make a little more sense out of it. I know that part's a bit confusing. Think of it like this. Does anyone remember how far u was? U was 4, v was? Okay. So we know u is 4. Well, what is 1 over root 21 times 4? Okay. And what is 1 over root 21, times 5, not equal to 5? What are these actual values? Okay. I'll try to make sense of this. That's going to be 4 divided by, and I'll do it on the calculator for you, second function, 21. 0.87, and the other one is 1 divided by root 21 times 5, 1.09. Is that what you guys got? I guess I'm the only one doing it. Okay, that's fine. 1.09. What that means, okay, our last chance to kind of try to put this all together is, remember we had a u and a v. Distance was 120 in terms of an angle between them. Right. Well, we know u plus v is essentially this vector here. It creates our parallelogram. Okay. Well, in order to make u plus v the magnitude of 1, okay, the absolute value of this, the magnitude of 1, our v vector, it looks like, needs to be 1.09, and our u vector needs to be about 0.87. Or in those cases, 4 times root 21 and 5 times root 21. When we do that, we discover that our new unit vector of the same direction will be of a magnitude of 1. So that's what all of this did. It just gave us a unit vector, uv, of a magnitude of 1, and it told us what we had to scale the other two vectors down to in order to get that number.